Okay, so this will be our 7th tutorial. We'll be making a hinged box, but we'll look at some different ways that we can create boxes or cases in this case, and make them parametric for 3D printing. So I've already saved my file here. I've just titled it hinged box for 3D printing parametric. And what I'll do is, this is quite important, I'm going to just make a new component first. And I'm going to name this the bottom box. Later, our parent will be the main file. That's fine. I'll hit OK. And so now that I've got my component, you can see that my component is activated. What I can do is I can start to sketch and create my features, and it'll all be reflected in timeline for this component. So I'll start off with a sketch, and I'll select the bottom plane. I'll select it. And here I'll create a rectangle. In this case, a 2-point. I'll select the center, and I will make this 70 by 70. Alright, we're going to make a sort of like a cube. We'll click left click or enter. We'll finish our sketch, and here we have our sketch. Now, you don't have to do this. The reason I'm showing this now is because I want to show you that instead of using or manually inputting your dimensions, you can always use the change parameters tool. Now I find this very useful, so what I do is I have it as a shortcut here reflected on my workspace, but you might not have this here by default, in which case you can always go to change parameters. On the 3 dots here, you can click it and select pin to toolbar. So with that, next time if I ever want to go into change parameters, I can either search for it here, change parameters, using the S shortcut, or I can just click here. I'll just click in this case. And so now what I want to do is I want to set up my user parameters for my box. And in this case, I'll just enter a new one by clicking the plus user parameter. Now the name is what you're going to be using to refer to this dimension, right? So the first one I want to make is the thickness of my walls of the box. So I'll just name this wall thickness. And you'll notice that you won't be able to put spaces in between. So it's kind of a useful habit to put a capital, I think it's called camel case or something, but you put a capital for each letter just so you can see and understand better. For my expression, this is the value that I want. So in this case, I want it to be 70. So I'll type 70. Oh, sorry, for my wall thickness, I want it to be 1.2. So the reason why I'm putting it to 1.2 is, if you think about it, if I'm 3D printing something, the default layer height you usually print is 0.2 millimeters layer height. So if we want to have 3 walls on each side, so a total of 6 walls, then 6 times 0.2 is 1.2. So in that way, you definitely have a very sturdy wall without having to put any infill or extra wall thicknesses. In this case, you can play around in Cura itself to also increase the wall thickness if you want. But for now, I'll leave it at 1.2. For comments, this is essentially telling yourself or your colleagues that this parameter is referring to this object. In this case, I'm going to, for the sake of this demonstration, I'll just say the thickness of the box's wall. And I'll hit OK. And so in future, whenever I am not sure what wall thickness the name means, I can always refer to the comments. I won't be doing this for all of them, but just as an example, you can always add comments. So I add a new user parameter, and this time I'm going to call this box height. And I'll again put this to 70 since I want a cube. And I'll leave comments empty for now. And the last one I'll put is gap. And you'll see what gap is in a second. But for gap, I'll just put 0.5. You can always put it to 0.6 if you want, but usually Cura is fine with it. So I'll put 0.5. So when I'm going through the tutorial later, I'll be adding more user parameters just to demonstrate how you can fully constrain your model and make it fully parametric. But for now, I'll just leave it like this. I'll hit OK. And so now I have my sketch already, and I've got my user parameters. So again, what I can do is I can press E to extrude. If it's not already selected, select the face. And I'm going to set this dimension to box height. And you can see as I type box, it's already going to prompt me for the user parameter. I'll select that, and it automatically extrudes it to 70, as you can see right here. So I'll hit enter. Now I've got my box, it's 70 millimeters high. And next what I'll do is I want to make this box hollow. Now if you remember, previously when I shelled my models, I will always select a face. Let's just say this for example. I'm gonna hit 3. And you can see it shells, right? But it always cuts away a face. So how would I shell my box but without having to remove a face? In this case, I just want this to be hollow, but I still want this top wall. So what you can do is instead of selecting your face, you can select the entire body, right? So I'll drop down here in the drop down menu, bodies, and I can select the entire body, right? Alternatively, you can also select each face or side of your cube. It's a lot simpler to just select the body, so I'm going to select the body. I'll hit OK. And now you can see I've still got my cube, there's no face missing. But if I go and check using the section analysis, you can find it here. Again, I find it very useful, so I've pinned it to my toolbar. Section analysis, I'm going to just select one of the planes. And as you can see, my box is now hollow. And so now that this is hollow, I'm going to hit cancel. What I want to do is, like our molds, I want to split it in half so that I can open my box. In this case, I'm going to use a mid plane to get the exact middle. I'll select the top and bottom faces, hit OK. And now I can split my body using the split body tool. So again, I'll select my body to split. I'll select the splitting tool as the plane that I want to cut it on. I'll hit OK. And now I have two bodies. So what I can do here is I can hide my plane. One second. So your planes will appear under construction. If you were to hide the entire construction tab, then in future when you create new construction planes, they're not going to appear. So it's a good habit to just select the plane, the specific plane that you do not want. In this case, that's the mid plane here. And if you can also, as a good practice, name your plane. So I'll just name this mid plane for the box. That's fine. And so right now I have my box, and in this case I want to give it a hinge. So there are many different designs for hinges. In this case I'm just going to do a very simple one because I'm making it for 3D printing. And so what I'll do is I will create a sketch. But actually, as you realize, I'm still working on my bottom box component. So what I can do actually is go to my face. So I'm not sure which body is referring to which one. I can either click on the body itself and it'll tell me here. You can see it's underlined. Or I can hover over the body and it will show me which body it is. So in this case, body 1 is my bottom box and body 2 is my top one. I'm just going to right click and I'm going to create components from body. What I've done here is I've essentially created a component, but by default it will put the parent component as the component that I'm activated currently. If you ever find that you want this to move and be a part of a subcomponent of the main thing, you should be able to click and drag. And now you can see by clicking and dragging my component, a little tab in the browser, it is now a component of the entire design itself rather than of the bottom box. And of course, doing it this way allows me to look at the components and activate them separately. You can see my timeline has now changed. If I make edits to this box, say I draw a pattern or I make some fillets, then it'll be a lot easier to work on it in this way. I'm not going to get confused by the other timeline histories. So anyways, I guess I'll just leave it for now. If it gets in the way, I'll fix it. But I'll call this the top box. If you can click to rename it. If not, just right click and rename it somewhere in here. Rename over here. But anyways, what I want to do is I want to again go back to my bottom box. And actually what I'll do instead is I'll just go and activate this entire component. It's just easier for me again. But just to note, by doing this, any bodies I create are going to appear in my main design instead. But again, I'm not going to put any features on this box, so it's not a big deal. Anyways, I want to make the hinge. I've decided this is my front, same as the view cube. So I'm going to create a sketch on this face, the left side of the box, if you think about it, or the right view plane. So I'm going to create sketch, and by selecting the face, it's going to give my sketch on that face itself. And this will also allow me to refer to points or edges on my face. So in this case, what I'm going to do is I'm first going to create a mirror line. So I'll draw a line. You can press this button or L. I'm going to click on the very edge where it meets. I'm going to bring it out and I'll just make it any, well, I'll make it 2.95 millimeters. Right, so let's just say I can't see right now, it's fine, I'll just click like this. I'll hit escape to stop the line. And it's very clearly not straight. So what I can do is I can select this and I'll hit horizontal, vertical constraint. So now as you can see, it's black, it's fully constrained and it's horizontal. I'll click on it and press X, or I can click the button here and make it a construction line. And what I'll do is make 3 circles. So I'll just make them any size right now. I'll just click out. Again, I'm using the shortcut C for circle, or you can find it here. And I'll just make 3. Okay, so now it's quite small. I'm going to zoom in with my scroll wheel. And I'm going to select D for dimension. I'm going to select the first circle here and the inner circle. I'm going to drag out so I can see my dimension. And here I'm going to type in wall thickness. So wall, you can press W, hit enter. You can see it's automatically constrained and dimensioned. I'm going to click the second one and then the first one. So now it gives me a dimension in between the circles, as you can see here. So again, I'm just going to move this out of the way, put it here, and I'm going to put this as gap. Hit enter. And lastly, for this one, I'm going to select the last circle, the most outermost circle, select the second or middle circle, and again give this a dimension of wall thickness. Enter. So now I've got my hinge, or at least the rod that will go through, and the outer body that will rotate around it. So in this case, the gap here is so that there's some space, such that when you open the box and you rotate it, it doesn't bind to the rod itself. You can always change this in the user parameters, and that's the point of it. But for now, what I want to do is connect this circle to my body. So in this case, I'm just going to press L to bring up my line command. I'll select the edge here. You can see it's highlighted. I'm going to bring it up to my circle. It should snap to the edge. And if you look around, you should be able to find the tangent. So it'll snap into the tangent line here. And this is just one way that I can apply constraints easily. So in this case, I'll put my tangent. You can see there's a tangent here. And now what I'm going to do is I'm going to hit escape. And I want to dimension the angle between these two lines, right? So I'll select the line that I drew. I'm going to select the line that I drew it from. And here I can either place it outside or I can place it inside. In this case, I want it inside, so I'll place it inside. And I'll give this a 45-degree angle, like so. And you can see because it's been constrained here and it's coincident here, it's going to automatically move the line to fit those constraints. Now I'll just show you as an example. If I do the same, let's just say I missed this line. What I can do is I can just hit this and I'll just put it here so it's clearly not tangent. Again, I can select this line. Actually, what I'll do first is I'll coincident this line to this. So I'll hit the edge, I'll select coincident, select that line, and now you can see it is touching the line. So remember, you have to be quite familiar with what each constraint does. Play around with it. As you get more experience, you'll sort of understand how to use them more effectively. So again, I want to make this line tangent to the circle. I'll click the line, I'll hit the tangent constraint, and I'll select the circle, and as you can see, it is now tangent. Right, and lastly, again, just to dimension this and make this 45. So here you can see I've got my hinge shape working. Actually, what I'm going to do, I realized, is that you can see my face is selecting the entire profile, and that's because my line here is a construction line. So if I ever realize, you know what, I actually want this to be part of my design, it's very simple. I can always click on it and hit X. So now that I've made it a non-construction line, you can see my faces can be separated. And when I go to extrude it, you can see that now I can select the faces correctly, right? In this case, we have our sketch. We are going to finish our sketch. And in future, if I ever want to refer back to it and change it, especially if I have many sketches, so you can see the sketch I created because I've activated this component. It reflected here and not under my other components. That's fine. Again, I don't really care. I'm going to go down to my sketch. Again, I'll rename this to Hinge. You don't have to do this. It's just good for housekeeping and organizing your design. Okay, so now what I want to do is I want to extrude this body all the way to this face, right? Now I know that my face is, the length of my box is 70. So in this case, what I'm going to do first is I'm just going to hit E, and I'll select, not the first one, sorry, the bottom one. And I'm not going to select the inner circles because this is going to be part of my box. What I'll do is I will, instead of typing 70, which, oops, in this case negative 70, to do this, instead of doing this, what I'm going to do, because I want to make it parametric, and if I did this, I'll have to reference it all the time. I have to manually enter a parameter. What I'll do instead to let Autodesk do it for me is change this to toObject, right? So similar to, I believe we did it back in the handlebar one. What it does is if you select the face, it's going to move this or extrude this to the face. So in future, when the box, if it becomes slimmer, then this extrude function is going to always extrude this profile to this face, no matter the size or the length. So the defaults are fine. I am going to hit OK because I'll join it. And in this case, you can see I have my body here. So now I've got my hinge. Of course, this won't work as it is now. That's fine. I'm going to reappear my sketch, and I'm going to repeat that. But I don't want to get in the way of my bottom box. So I'm just going to hide this here for the time being. I'm going to press E again. Now select the other side, the top side this time. And same thing, toObject, select my face, which is over here, join, hit OK. And so now I have two hinges like so. And you can sort of see what I'm going for, right? It's got a hinge and you're going to move it back up and down. But of course, as of right now, these bodies are overlapping, so I need to fix that. And what I'm going to do before I do that is to hide both bodies. So I'll hide the top box and the middle. I'm going to select the center one. This will be my rod. And again, if this hidden, what I can do is I can just show one face. Select the face again. Forgot to put toObject. Select there. So you can see it's going to go all the way to the same face. In this case, it's not actually touching my body, so I can just click OK. But just in case, especially if there's some internal geometry, a good habit is just to hide it. See your shape that you're making. It's going to be a new body since it's not generating to anything. That's fine. Hit OK. And now I'll have, as you can see here, my hinge, right? I'll just call this a rod. I'll rename it. So as you can see, by activating different components, I have different bodies, different sketches, all organized accordingly. It'll take some trial and error to sort of get used to organizing it the most efficient way. Typically, I like to just put all my bodies in one design for a very simple design, but this is just to demonstrate that you can organize your designs accordingly. So now with that done, I've got all the components. I need to start to create spacers, right? So they don't intersect with one another. In this case, I don't need this sketch anymore. I'm going to hide it. And I'm hiding it here because if I hide it here, then I won't be able to see any of my sketches. So what I'm going to do is create a sketch. And I'm going to select this face here because this is my center plane. If I want to be doubly sure, I can always select the mid-plane box, but by doing it this way, I can always reference features from my box itself. So I'm going to select here. Right now, it's showing me this angle. I don't want it this way. I can select the arrow here to rotate my view. You can see here, it won't appear unless you hover over your view cube. But using these arrows, I can rotate my camera like so. And so now my hinge is going to be on the right side. What I can do is I can hide my body. So I'll hide it for now. I'll hide the rod as well. And you can see here, I can still reference my box design because I selected the face as my sketch plane. So in this case, I'm just going to project, if I can. No, I can't. It's always finicky. But that's fine. I can still use my line tools around that, so that's okay. I'll create a rectangle. And I'll put it on this edge. It's a little bit hard to see. There's a blue highlight. That's just the box. If you ever get lost, you can always show your box again, which is over here. And reference off that if you like. In this case, I don't need to. I'm going to select the very edge of the box here, the blue highlight. And I'll bring this out by, let's see. This will be the wall thickness. So select that. I'll press tab to select the other side. and I'm gonna make my hinge 5.5 millimeters long. It's like this. My sketch is constrained, it's fine. What I'm gonna do is repeat that. I'm gonna select the 2-point rectangle, or you can always right click and repeat here. That's the last tool you used. I'm gonna select the other edge, and I'm going to create a gap line here. So this will be gap. And again, right now what I can do is I can always just click out of here. And because I know that this length, the dimension here I'm going to put here, needs to be the same as this, I can dimension it, select the dimension here, hit enter, and now if I were to change this, let's change this to 3, for example, you can see both my dimensions are changing because this is now referring to this dimension. So if you don't want to create a new user parameter for that, you can always do this instead. We've explored this a little bit in previous tutorials. So now with my little corner done, what I'm going to do is I'm going to find the mid line here. And again, I sort of have a visual of the box in my mind. If you can't tell, you can always look here and see, right? So this is the midline. You can tell because there is a triangle. I'll hide it so it's a bit easier to see. That's a triangle constraint. I'm going to select this and I'm going to extend this out. Doesn't really matter how far. I'm going to make this a construction line because I'm going to mirror this. And what I'll do is I want to create a sort of space. I want a little middle part that's always a third, essentially. So I'm going to bring this out. I'm going to snap it down to here. I'll make this, let's see, 11.5 millimeters. Again, I don't need this to be part of my design. I'll press X while with it highlighted to give it that dimension. And I'll move this out of the way so it doesn't get in the way. So last thing, I'm going to just create another gap rectangle. Here I'll make it gap. Click on it here. Again, what I can do is I can dimension this point to be the same as this one. Enter. And now I have 3 separate rectangles. They're all fully constrained and I have a mirror line. So in this case, what I'll do is I'll go to mirror. I'll select it and I can double click on my rectangles to select all the lines as long as they're connected. I'll select the second one, third one, and now I should have 3 rectangles selected. I'll select the middle line here, which is my mirror line. Hit OK. And if I check, you can see that I've got my sketches mirrored perfectly. And they're going to be constrained because my mirrored sketches are constrained. So with this done, I'm going to finish the sketch. I'm going to show my bodies again. In this case, I'll show both. I'm not going to show the rod because I don't need it yet. And what I'm going to do is I'm going to extrude up to cut away the material from here. So in this case, I'm going to select the gap rectangles, which is the second from the last. One in the middle, or the 2 in the middle, and then the opposite. So it should be something like this. So select every rectangle except the far ends, the ones on the far ends. Okay, and now I could always extrude it out to cut, and I just realized, okay, yeah, so I've messed up. So you can see that my rectangles aren't actually cutting all the way here. That's to do with the sketch. So what I'll do is I'll go back to my sketch. I think it was here, was it? Yeah. Okay, so as you can see here, I actually want this rectangle to be in line with this. So a simple way I can do this is just project this line. And if you think about it, when you're looking at this line from the top, it just appears as a dot, right? Because it's 2-dimensional. So by projecting it from this point, it appears as a dot here in purple. So I'll hit OK. I'm going to hide my bodies again just so I can see better. And you can see I'm off by that distance. So to save myself time, I'll just remove the coincidences. I'll click on my part here, coincident, and it should move. If not, this must be some other coincident. Yeah. 1 second. Does this move now? Okay, yeah. That's fine. Sometimes when you mess with the coincidences, it breaks. So I'm just going to redo this again. 1 second. Very fast. Oh, done. So alright, let me just bring this back. So what I've done is I've accidentally deleted my point. Have I? Was this the point? Yeah, that is the point. Okay, sorry. So Again, this is my point here that I'm going to start from again. I'm just going to, again, create a rectangle. I'll name this wall thickness. Bear with me. Oops. Okay, 5.5. Okay, I'm just going to double check. So it's in the wrong direction. That's okay. I'll change this to negative to make this go in. Oh, wait, yeah, you can't do negatives. I forget about that. Hang on. So what I've done is I've accidentally put it on the wrong way. That's okay. Just to sort of show you, the reason is because I put it this way when I type the wall distance. If I go this way now, it should fix that. So what happened there? 5.5 wall thickness. Yep, and it's this way now. So let me delete this. Sorry, sometimes Fusion bugs out. Just wall thickness. Okay, so now I've got my dimension again. Just quickly, I'll just put another one. This will be gap. Gap. Okay, it takes a while. And then this will be, I'll just put it here. Dimension this, same as always. Again, put the middle line. And what I'll do is just to make sure I'm in line, I'll just draw a straight line up from the point that I started. Actually, I've kind of done this the wrong way. What I should do is I should just go to my box. I'll project this line instead, because this is the length. Hit OK. Yeah, so I've got my line here. I'm just a little bit concerned because if I do projections, it might break things, but it should be fine. I'll leave it as is for now. Okay, so line there doesn't have to be dimensioned. I'm going to make this 11.5. Enter construction line as well. Then lastly, just draw my rectangle, make it the same as my gap, which in this case is gap. Hit this, dimension this, make it the same as that. And then mirror. Okay, so now if I check, it should be properly aligned this time. I'm going to extrude the same boxes as before. Also, I just noticed, but there's a line here for some reason. That's fine. I'll just select inside. Hide this. So make sure to select all the faces. Okay. And now if I do this, it should align. Yep. Okay, so now you can see it's properly aligned. That's fine. Now I could do it this way. I could just go symmetric and cut this on both sides. You can also cut all, in which case it will only cut to the face, like so. So I'll just do all, just so that if I were to ever increase the size of my hinge, I, again, like the extrude function, it is going to the face rather than a dimension that I set it to. So in this case, my objects to cut will be my body. That is correct. We'll hit OK. Give it a second to load. And so now you can see that I have all these hinges on my box. In this case, I want the bottom one to have 2 and the top one to have 1 in the middle. So all these are now excess bodies in this case. So I just realized that all these are already joined. So maybe what I should have done is for the extrude, I'll go back because I made a mistake. I'll go back, instead of join, I'll just do new body. Hit OK. Now I can see I can select the bodies individually. I'm going to do the same thing for the top one. And this is sort of a demonstration as to why it's helpful to use the timeline in your design, because sometimes you might decide I want to make certain changes and it's easier to just go back and fix it here in the extrude rather than have to redraw sketches and add additional extrusions. So now that I've got my bodies, what I can do is I'll show it here. Again, I want to remove these two, and I can't tell which body numbers they are. That's fine. By clicking on them, I can see here that it's highlighted. So if I click on these, right click and remove, now they're removed from my box essentially. What I'm going to do now also is I'm going to remove the middle one from the bottom. So again, select it, remove. And so now I've got my bodies here. That's fine. What I'll do is I will combine them now since I have it all done. You can sort of see what I mean, right? There's a hinge here, and this, by doing it this way, I can allow it to rotate without getting in the way of the box. So I've got all the bodies here. This is my main body that I want to combine it to, and again my top box is only going to have this middle part as well as the edges here. So just to make my life easier, I'm going to hide the bottom box like so. You can see what I'm going for. I'm going to go to the combine. I'm going to select my parent body, which is the box. I'll select the 3 edges here. I'll click join just to make sure. I don't need to keep the tools because I want it all to be a single body. And now I have my hinge box on the top side. Now with that done, I can hide this one and I'll show my bottom one. And if you look at it, you can see that, oops, if I have my body on, this part is going to collide. So I'm going to remove this. In this case, what I can do is I can always hide it. Oops, let me hide the top box first. I don't want this body here, this body and this body here, which is number 7. I don't want these. I can remove them, or if I'm combining and I want to keep them for whatever reason, I can always just hide them and then combine. In this case, I'm not going to do that. I'm just going to remove them as well, like this. And now if I want to say reposition this because maybe this doesn't look nice, I want to have my remove all in one, I can always click and drag and reposition things on my timeline. It's not an issue. So from here, what I want is to combine these 3 bodies. So I'll do the same thing, combine, select the bottom box, 2 bodies, I'll select the 2 hinges. You can see they're all highlighted. Join, again, I don't need to keep tools, it's okay. And so now I have my hinge on the bottom side as well as the top part here, as you can see. So now you can see there are gaps. These are not going to collide or get in the way. And if I have my rod in the middle here, you can see there is a rod for it to rotate around. So in this case, I want my rod, let's just say, to be affixed. Since this is a print, okay, so if you're going to print this separately, you can. As of right now, you could always print just the 2 boxes, and you can insert like a metal rod or whatever rod material of your choice into here after the fact, right? But right now we want to make a box that's specifically designed for 3D printing, so it's a print in place essentially. In this case, we're going to carry on from here. We're going to show our rod again, and we want this rod to be connected to the top box here. It doesn't really matter. I find it's better to just connect it to the ends. So if you can see, oops, wrong one. You can see here, if I were to connect my rod to this end here, or these 2 ends, then it's a bit simpler rather than if I were to connect it like this. There's a little bit of a gap here, right? It sticks out, which isn't the best. Again, it doesn't really matter. Just choose whichever feels best. For me, I'm going to go with the top one. And so now you can see I can't combine this one, because if I try combine, you can see that it's not actually, how do you say, it's not actually got anything connecting to it, right? So it's going to be just 2 bodies separately in a sense. So what I can do is I could extrude this if I wanted to, or actually that wouldn't be a very good thing, because then I have to create a sketch and you're adding more user parameters if you have to. So a good way you can do it is if you select this face and you can just delete it, and now you can see it's automatically filled the block in for you. So I select here and I delete it as well. You can see now I've got my rod going through my face, and don't worry if it shows the edge here. It's when you combine it, and I'll show you. Combine, you can see that this and this join, the edge is gone. So now this rod is together with the box. And I also realized that actually this doesn't have to be, doesn't need a gap, because again, we are just going to combine this together. So I can always go back in my timeline, select this one as well, hit delete, and now when I go back without having to change anything, it will also be combined, as you can see, because I've selected the body. So now with that done, if you look at it with the bottom, you can see what I mean, right? We have the bottom, which has a gap, if you can see here, a gap, and this will allow it to rotate, while this one has the rod welded onto it, and so it will just rotate around that middle axis. So with this, we've got our box done, essentially. what we can do is we can always press M, we'll select the middle here, rotate this 180 degrees, and print it like so. And if you're wondering, but hang on, isn't there a gap? Don't you need to put supports? Well, because we've set our wall thickness to 1.2, see if I look in the section analysis, hang on. Okay, you can see that actually what will happen is it will print a straight line, but we have it encased and it's thick enough that as it's printing the lines, you don't actually need to support it. It won't be the best. Obviously, this will play with isotropy and whatnot. But if you try it out yourself, you should be able to print this and have it print in place without the use of supports. Alternatively, you're really very worried and you want again to have very smooth motion, then go back a few steps before I combine everything and you can insert the rod yourself. But I don't want this, so I'll Control Z to get back, and I'll undo this move command because I want to show you something better. What we can do, and we're going to touch on this in future tutorials, but we'll start to look at joints. So the joints will be found under the Assemble drop-down menu, and that's joint and S-build joints. Again, I'll explain more about the differences in the future tutorial. We have a separate activity for that. But for now, we're going to select S-build joint. We're going to select our components, which is the top box and the bottom box. We're going to select our type, and we're going to select the revolute option. So here we're going to select our origin first, which is the point here. That's the center of the rod, essentially. And you can see Fusion automatically previews that motion. If I want to re-see that, I can always hit here preview motion, and it'll show us how our joint actually works. In this case, it's going through the bodies because it doesn't understand that that it can't actually go through this in real life. Don't worry, what we can do here is then select our joint motion limits. In this case, I'll select the minimum first, and I'll just leave this as is, 0 degrees, and by default it has the maximum as well. You can play around with this using the arrows to rotate it. This should work as well, but if you can't, for whatever reason it starts to snap together, you can always just type it in manually. So in this case, now if I preview, you should see that it now confines to the angles that I've selected. So with this, I'll hit stop and I'll hit OK. And so now I've got a joint. I can always select this little flag here. I'll click on it. Oops, don't know why it didn't. So once I click on it, it'll give me a rotation. I can always just rotate this to 100, and you can see I can't rotate it further down. I can't rotate it further down because I have the limits. So now I'll leave it like this. Be okay. I hit enter, and if you haven't noticed, something popped up here on the side. There's a position, which is capture position or revert position, and that's self-explanatory. If I hit revert position, it's going to put back my position. So whenever you make changes to your joints, you move these joints, Fusion is going to ask you, do you want to capture these positions or do you want to leave them alone? Because let's just say now I want to model something on the inside of the box, right? I've got my joint here. It's a bit finicky. So I'll move this back to 180, hit enter. And let's just say I want to make this smaller. I want to extrude this up. It's going to ask me, hey, capture or revert? Because if I revert it, it's going to revert it back. So instead, I'll say capture. And now, if I want to make edits to my body, I can. Because now I've captured this position here. So just capture, done. It goes away. You can work on it however you want, right? So that's just an intro to that. Now, remember when I said I wanted to experiment with the user parameters? I've deliberately left some out, so this is why. If we go back to our parameters and we want to make this box smaller, right? Let's say we want a box with a height of, let's just see here, so I can click on this. This will let me change it, and I'll make this 30, so about half. Hit OK, and now I can see my box has automatically been made more shallow, right? So this is a very handy tool. But now what if I want to make it smaller, you know, lengthwise and widthwise? Well, that's a little bit more tricky because I haven't actually put my user parameters yet, right? I only got wall thickness, box height, and gap, right? Again, if I want my gap to increase, I can always adjust it here. That's the point of parameters. So for now, what I'll do is I'll create a user parameter, and I'll give it a name of length. I can always type box length if I want. I'll just do that, box length. Although I tend not to do this, the reason is because if you think about it, if I have one that's named box length and box width, if I type in box, it's going to show me both. Whereas I already know it's the length, so I can always put length box instead. Right? For my expression, I'll just put 70, that's what it was before. Hit OK. And if I go and create a new one, I'll hit again width, and I'll do box. And similarly, I'll do 70. Hit OK. And what I'm going to do is leave this alone now. There's actually one more parameter I want to add, but I'll leave it alone. And so now, but I haven't actually added this parameter to a dimension, right? So I'm going to go all the way back to my first sketch here, which I can find in the timeline. And I'm going to change this. So in this case, this would be my width. So I'll type in. So now if I try and type in box, you can see it's got box height and stuff. And it shows me the width as well. If I put this all box, I have to look and read through both of them, which I don't really want to. So in this case, I'll just select width. I find it more useful to put your parameter you're changing first, is what I meant. Anyway, box width. Change this to length. In this case, box length. Enter. I'm going to finish the sketch. And so now, if I go back to my parameters, change parameters, if I change my width, let's just say 20, you can see I've changed it as well.
Okay, so it changes all over the box.
It changes based on the dimension that you selected, or you put the parameter for.
When you change it in the parameters, like
Because I've designed my box that way, yes. Yeah. So you can, this is very easy to mess up. This is a lot of trial and error. There's no like, this way works for all, especially with complex models. So you really have to just play around and sort of force yourself to learn this. But now I've got my width set. Let's change the length now. What if I want, let's just say a 25mm width, okay? Uh-oh, there's a problem, right? And this just looks horrible. Why is that, you think?
the hinge basically got squished into a thing.
Yeah, because as you can see, if I do Y, my hinge actually isn't parametric. My box is, but my hinge isn't.
We did delete the hinge, or did it just squish it?
No, it changes this. So remember I used an extrude to face. So because of that, it's taking the profile, the sketch profile, and extruding it from there now. See, oops. So it's just going to extrude from there.
Oh, okay.
So now what I've done is I've deliberately not put a parametric sketch in, essentially. So if I go back to my hinge here, remember how I said I wanted it to be a third of my box length in this case? So again, I'll hide it just so that I can see my sketch better and the rod. You can see here, I'm going to delete this. Delete it. Okay. You can see here that my gap here actually isn't parametric. I've given it a 11.5 diameter, length dimension, but I don't want that. So what I'll do is I'll say, look at the length, because we know that this line is the center line. So, and this face is aligned to the edge of my box, or it should be. I hope I'm not messed it up. So if this is going to move to the left, right? So let's say this part here. These parts here are going to move to the left according to the size of my box. The midline is always going to be the same because it's also part of the box. It's referring to the box. Then basically this gap here in the middle is what needs to be parametric. And in this case, what I can do is I want it to be a third. So if you think about it mathematically, right? We want this gap here, right? This is about a third of the entire distance. If this is half, then it's just simply my length box divided by 6. Should be by 6, yeah. And so now you can see this has been made parametric. Let me just... Okay, so what I've done is this hasn't actually been aligned to the sketch. You can see here, it's moving the mirror line instead. I don't want to do that. I also don't want to fix this because it's actually based on the previous sketch. So what I'll do is I'll show my projection line, and this is why projections can be quite confusing sometimes. In this case, I know my line is here. It's just for your sake I deleted it. But in this case, I know the projection needs to be there. So again, I'm going to do the same thing, length box divided by 6. Hit enter. and now you see the line stays still. That's because it is referencing the projection line. If you delete the projection line, then you're going to lose the reference, you see. So now my gap should, in theory, always be a third of my length, right? So I'll finish sketch. And now what I'll do is hit my view icon to show things again. That's the rod. Oh no, it'll be connected now. Okay, so if I go back to change parameters and let's just set this back to, what was it, 25 I used, I think. Hit OK. Now you see everything is aligned correctly. It's exactly a third in between. So this is where I feel a lot of beginners sort of get lost, because as you practice, you sort of understand what needs to be parametric or what needs to be related to the components that you're building. With a box, it's fairly simple. That's why it's a good example. But imagine if you were trying to make a hot press, right? What if you had rotational levers as well as buttons and things like this? You know, if you change the lever, how would that affect the press size? You know. So again, the good thing about Fusion is that you can use mathematical formulas, at least simple ones, to dimension your parts. So if ever you find any relationship, it's quite useful to do that. So in this case, I want my hinges to always be a third the size of my length. Therefore, I make it divided by 6 because it's from the center point, you see. So with that, I will just save this. And actually what I'll do is I'll save the entire thing. Again, if I want to save the entire thing, I'll right click, I'll save as mesh, STL binary, that's fine, one file is okay. I'll save this as printer box for 3D printing. Let me just save as well in Fusion, hit OK. Okay, so now if I open up Cura, I'll bring in the hinge box, and I'll zoom in. You can see I've got my model, and if I were to just, I'll just use a, actually it doesn't really matter. So I'll remove the spots or slice, preview, and you can see here that it's slicing my file correctly so far. If I bring down my, where's it gone? Okay, there. So what I'll do is I'll try to make this a bit easier to see. I'll change this to just material color. Maybe, yeah, I'll just do material color. So it might be a bit hard to see here, but if you can, let's try from the side. This part here is our rod, essentially, this line here. So if you look at how it would print, you can do this by here, you can see that there's a bridge, right? And so as it's printing, in fact, let me go down one more layer here. So this is where it's printing. This is where it starts to print our rod, this line there, you can see it. If I go into the path, you can see that as it prints, it's going to bridge this line. And depending on the size of your model, this should bridge just fine, right? So in that way, there's a gap. You can keep printing. It'll print more layers on, and there shouldn't be a need to support it. And so as you print this, you can see that hinge wrapping around it. This should allow you to print in place a hinged box, fully 3D printed. Alright, and it's got flat surface to print on, so that's fine. Earlier when I was creating this box, what I did was doing the shell command, which is over here. You can see that I absentmindedly put in 3mm inside thickness. But if you recall, we actually have our user function or user parameter that specifies the wall thickness. In this case, I put it to 1.2, not 3. So if I ever wanted to change the inside thickness, I wouldn't be able to because it's actually not dimensioned properly. So what I'll do is I'll go back to the shell tool, and instead of doing 3mm, I'm going to put wall thickness. See here, that's okay. I'm going to hit OK, and now you can see that my box has been shelled such that the walls are 1.2mm. If I put this in Cura, you'll see that there should be no infills so long as you set your wall line count to 3 and your layer height to 0.2mm. And so yeah, so that's our hinge box. What we can do next is we'll create a new one, and we'll look at some other type of box designs. In this case, what I want is to make a sliding box, right? So very simply, again, I'm not going to create a parametric model just for the sake of time, but I'll just create a box here, select it, I'll just make it 50 by 50, and I'll make this 50 is fine as well. Okay. And now if you think about a box, again, you need it to be hollow. So what I'll do is create, modify shell, and I'll select the entire body. Hit, yep, I'll do 3 again. Okay. And now if I were to section analysis, you can see here that it is in fact hollow, right? So if you've ever seen a sliding box, a very, very simple design is basically just to put a little dovetail wedge on the top. So I know that with 3D printing, 3mm is not very large. So what I can always do is I can, actually, you know what, I'll leave the section analysis so you can see what's happening. Yeah, sure, whatever. So again, I'll show the section analysis just so you can see, okay? So right now you have this. I'm going to select OK, and it will stay, right? And if I ever want to hide it, I can always go to Analysis. I can hide it here. So from here, if you think about it, this isn't very large, right? So what I'm going to do is, instead of extruding or whatever, I could, if I want, I can just offset face, and it should let me increase this to make it thicker. So again, offset face is just increasing the offset essentially of the face itself while keeping everything the same, right? If I were to extrude, I could always do that, but then I'm kind of creating a bit more of a headache when I'm trying to look at what I'm doing in the timeline. I find offset is a little bit better. Play around with it. I'm just more used to offset. So I'll just do not so much. I'll just add it by 2mm. So that way I have a thinner wall and a thicker head where I can actually put my slot in. So right now, the good thing about this section analysis is that we can sort of see our part and we can model it based on that, right? So in this case, I'll create a sketch. I want it to be based on this here because I can extrude it out. And so I'm going to go back. What I'm going to do is I'm going to select my line, and we'll just make it, let's just say, let me think. We'll do it here. I'm thinking if I want to make it center. Yeah, actually, no, let's make it center. Okay, so again, I'm going to make a center line. And again, I can tell it's centered because I have that triangle. Make this construction. And what I'll do is I'll just create another line here. I'll make it 15. I think that should be enough. Let me think, is 15 enough? It should be. Yeah, it should be fine. Actually, you know what? I'll do 20. Yeah, 20 might be better. Okay. So we go down this way. So we want it to stop, right? So we're going to go down this way. And we can always select our end here. So we'll just make this 135 degrees. I'll press tab to select it. And you can see now I can adjust my length. Because I don't know what the length between that is, right? Unless I'm a math genius. So I'll click here. There's an X if you can't see it, but there's an X that shows me that I'm on the line. And what I can do is I can then just click on this again, and I'll bring it to the center line here. So you can see how it snaps. And so now if I hide my body, you can see I've got my sketch like so. Right, and again, I'll just mirror this, select my objects, select the mirror line, hit OK, and I've got a fully constrained sketch, as you can see. So this will sort of be my lid. And now what I want is I want it to have, I want it to not cut through my entire body, right? So let me just show the body again. I'll finish the sketch first. And so now if you think about it, let's just hide the analysis. If I were to just take this plane and just cut it through, then it's not really a sliding box, is it? It's more of a, how do you say? It's just like a cap, I suppose, right? It's just a lid. So what I want to do instead is I want to make sure that this actually is going to stay inside. So the way I do that is instead of actually having it slope inwards this way, I'm going to slope it the other way, right? So I'll go back to my sketch. And here you can see I've got my angle. Now I could redraw my sketch, but that's a little bit tedious. So what I can do is I can change this angle And obviously if I have something above 90 degrees, it's going to be obtuse. I want it to be acute in this case. So I have a 135-degree angle, and I want it to be, let's just say, 45 instead. So I'll hit 45. And now it's, because it's constrained, it will automatically do that, right? But of course now it's going to cut out. What do? Easy. I have this dimension as well. I can go back here and bring it back to 15, you see? So just like that, I can always make easy changes to my sketches as long as I drew them correctly the first time. That's why it's important to dimension your sketches and make sure they're fully constrained. In this case, maybe 45 degree might be a little bit too much. I'll just do 70. That looks fine. And again, see how easy it is to change things. I can always go back to 20, and that's fine as well. So I think 20 might be a bit much. I'll just do 18. That's fine. So I'll finish the sketch, and now if you can see, if I were to cut this out, this essentially is going to let us slot in our body, have it stay there, and also if we were to turn this box upside down, it won't come out, right? So that's how you can sort of make changes to your design on the go if you want. In this case, we don't want it to go all the way through. We want it to just sort of go in, hit the end. For this, I don't want this to have a little thing sticking out. So what I'll do is, in my extrude, I'll just go back, and instead of extruding to a distance, I'll select the face at the back here. And when I hit OK, you can see this is all one face now. This is exactly to the edge of my wall, or the inner wall. And so the good thing with the sketch is I can then show it again. And with the same thing, I can select my sketch and extrude it out to the same one, and instead of selecting join, I hit new body, and I have my lid, as you can see, right? Now the problem is, if you were to 3D print this, there's no tolerance, right? So how do we adjust the tolerance? Very simply, we can always go back to our sketch again, and since this is constrained, all I have to do is just offset these lines, and I'll give this a, I find 0.2 works okay. You may want to do 0.4. We'll just do 0.4 because it's easier to see. We'll hit OK. Finish sketch, and because we haven't made a change to extrusion, it's still going to show us the old extrusion. That's why we go back to our extrusion here, the one for the lid. So just make sure you're selecting the right one, not the cut one, and we'll select only the inner face here, right? We don't have to change the extrusion because again it's still referencing the face, and we want to be extra certain with parametric modeling. You select two objects. In this case it's not parametric, so I'm not going to bother. But now with this, you can see, if I hide my sketch, that we have a lid that is got some tolerance for 3D printing. And again, you know, if I'm looking at it like this, the lid actually isn't as tall as this. So maybe I'm thinking, you know what, I only want the tolerances to go from the side. I can always offset the faces like so, or I can go back in, so I can offset it, say like here. I'll select the top face, and I'll select the top one. Oops, not the top one. I'll select the arrow to drag up, and I'll offset to exactly in line with this. That's why I like the offset tool. But alternatively, just to make things simpler, especially if you're making parametric models, instead of this offset going all around, I'll delete this. I'll just offset on the sides. If I can. Oh, no, I can't. So what I'll do is just draw a line. And this is where constraints can be useful. I'll select this line. I want it to be parallel to this. Select the parallel constraint. Now I dimension the distance between the two. In this case, I want it to be 0.4. Okay. And I can just mirror this again. Okay. You can see I've got my profile adjusted. Finish sketch. You can see it's warning because now I'm missing my profile because I deleted it before. So I'll just select this one again. Don't have to make any changes. And there you go. You have something that is now flushed on the top but with tolerances on the side. Again. So there are many different ways you can do this. You can do it in the sketch. You could even just go back to the start and just select these faces to offset. I could just select this face, offset, and just bring it down. You see? Just do what is appropriate for your parametric modeling. In this case, I'm not doing any. So I'll just do it this way. Also do something that makes it less cluttered in the timeline. In this case, you can see it's getting a little bit cluttered for what it is, but it's fine. So now that I've got my box, before I make any changes, what I can do is I can just I'll make that joint animation again, and I'll introduce you to another joint. In this case, I'm going to select as-built joint again. Oh yeah, so this is actually a good point. So what I've done is I've not created a new component, right? Now joints do not work for bodies, they only work for components. And that's why my printed box here works, because I have two separate components, you see. If I try to do the same thing here, create a joint, you see I can't. There needs to be components. And again, we can always employ the same tool, right click, create components from bodies. I'll just name this box. Again, right click here, create components from bodies, and I'll type this the lid. Okay. And so now I've got two components. If I try again as build joint, now it lets me do it. You see? So I'll select my bottom component here, as well as this one. These are the two things I want to basically move in relation to another. And instead of the revolute, I'm going to select the slider. Okay? And what the slider does basically is it lets me slide, essentially, right? It's a sliding tool. So, like so. In this case, I've selected this body, which I don't want it to. I think I need to be a bit more precise. Where's it gone? Hang on, let me... Sometimes it bugs out. Let me just redo this. There's a fix for this if it doesn't work, but don't worry. Slider again. So I'll select my... I think it's the bottom first and then the top, right? Should let me. I'm not sure why it isn't. What's working just now? Oh. The axis. Wait, so what I'm gonna try, again, I'm not honestly very familiar with joints because I don't tend to use them a lot, but let me just do this first. So if I want this to stay still, I'll just select the one and I'll select rigid. Oh wait, because you need to weld it together, yeah. Okay, never mind. Let me just try and make this work. Slider. It should... I'm selecting the wrong edge. Hang on. Yeah, I'm not very sure why it's moving this one instead. Yeah, maybe if I select that first. There. Oh, you did? Oh, okay. Let me just try this because I'm also curious. Will not revolute slide. Yep, there you go. So the mistake I made was I selected the box first. What I should have done is select the lid. So again, with the slide, you can also set the minimums. You saw how I was cutting through. So I'll select the minimum. I'll just leave it at 0. The maximums I'm going to set to, let's just put it here, 40. Right, so it's kind of like a sliding door. Hit O. We'll preview it again. You can see it's moving correctly. That's fine. We'll hit OK. And if you haven't realized, what do you think is one design flaw of this box?
Wait, will this, the bottom won't fuse?
Hmm?
The bottom will?
No, we don't have to print this in one part. You can print it separately. But what about our design? If I hide the lid, you might see. What's our one design flaw in this case, you feel?
Oh, overhang. It's at 19.
So,
like that bit, right? Like under the...
If I create a section analysis,
Yeah,
here, hang on. Show the lid. You can sort of see from here. This part here is basically a cantilever.
Yeah, it's not...
And so it's gonna fall right in, right? So it sometimes helps to sort of look at your model and see what might need to be fixed. In this case, what would you suggest I do to fix this? No, print it separately. No, this is not about a print in place. This is if you slide it in, right? If you think about it, this is it's gonna droop down, right? Because this is only 3 millimeters and this is like so long, and it's gonna probably weigh some weight. So how would you stop this from falling down, you think, in your design? Sorry?
Add a taper. Like,
Where?
could you remove the top section, like the sliding bit? Yeah, underneath that.
You get what I mean, right?
Maybe.
How would you fix this? How would you make this sliding door slide in, stay perfectly still, and not droop down? You think? I mean...
Extend the edges both ways.
So you
And
could...
you should place them on those edges only.
So what do you mean, like cut it all the way to the end?
Extra surface from inside of the box.
You can if you want, yeah. So what you could do is you could always put like a, let's just say a very simple fix is I'll just create a sketch here. I'm gonna rotate it so I can see. Let's just say I put a
can't you just put it
rectangle. Let's just say it like that, okay? It's a little thing. Okay. Finish the sketch here. I'm just gonna do one side just for demonstration. Again, pull it, I'll select the face here. Join, that's okay. And now you're thinking, oh, but there's an overhang, I need to support this. Well, you can always just chamfer this, pull it down to however much, basically up to here. Or you can also use the draft. I prefer the draft personally. You select the pull direction, which is here, and you can rotate in, like so, because you don't need to be very thick, right? So, hit OK. And then now you technically have like a little slider slot that you can still 3D print without supports. So that's one way you could do it, but then you're kind of reducing the size of your hole, right? I mean, if you, let's just undo this analysis. If you imagine both sides, it might make your hole smaller. So of course,
Why don't you just
hmm?
see that this taper, right?
Yes.
Just keep it going all the way down.
No, but it'll still fall down because it's not holding. The reason, if we turn this box upside down now with the lid won't come off because this taper is holding it up, right? But there's nothing keeping it from going down. So if you sort of visualize it, let me just show the thing again. It would sort of look a little bit like when you put it in, it would do that. You get what I mean? A little bit.
Yep.
So that's the sort of problem we're trying to fix. And we have one way we should just add a lip, but then that's going to reduce our surface area that we can use. I'm going to just Control Z to get rid of that. Yeah, but you could also just add a rail, right?
That's what I mean, like a bridge. Sorry,
Well, a rail, yeah. So in this case, let's use some of the tools we learned for making the molds, right? What we're gonna do is we're going to create a sketch, but we're gonna make it have a rail, right? In this case, so I'm gonna select this face here, create a sketch. And remember, because I'm creating a sketch on the face, my plane is gonna be oriented to that face. You can see how it angles like this. I'm gonna select look at, so I can get it front on essentially. And what I can do is I'm just going to create a rectangle that goes from one edge. Again, I can dimension this if I want, and I'll just make it, let's just say we want our box to just go up to about, actually let's just say here. Okay, so we'll hit there, that's okay. We'll dimension this just to keep things equidistant. So I'll just give this a 1, actually maybe not so much, oh that's too much, 1.5, yeah, that's fine. Give this a dimension as well. We'll make this 1.5 as well. And so now we have our line. We can also dimension this away. I want it to stop 1.5 away. So now I have my little rectangle rail. What I can do is I can always just fillet the edges, right, to make it more smooth, but I'll just leave it as so. But when I have this, I'm just going to check what the inner width is. I'm going to create a driven sketch just to show my dimension, and so it's telling me about 2.3, right? So now when I make my slot to go with it, I'm going to make it about 2 millimeters or less than this value basically. So the dimension here won't affect your sketch. It's only going to show you what the distance is. It's a what's it called again? It's basically a dimension that reflects a value but isn't actually playing a part in your sketch constraints, unlike these ones. So if it's in the bracket, it's not actually going to constrain anything. But regardless, what I'll do is I will finish the sketch. I'll increase this, cut, and now I have a rail. I can make a complementary cylinder or sphere, and now when I put it, this rail is going to help me hold on to it, right? But of course, now you have to worry is that you have an overhang here. Okay, so I'm telling you all this because if you're designing for AM, these are things that you have to think about, because with conventional modeling or molding, you don't have to worry about all this sort of stuff. Right, but in printing for AM, you have to be very aware of how your printer works, limitations, and how you can adjust your model to that. So instead, what I'm going to do is I'm just going to do something a lot simpler. I'm going to undo everything. It's good if you follow along anyways. That's fine. And instead of my rectangle, I am just going to put a line. I'm going to select from the center here, and I'll just drag it out however far. Doesn't matter. Just make sure that this is straight, essentially. Which I know it is because there's a perpendicular constraint. Anyways, finish our sketch. What we can do now is we can create our plane. Where is it? Plane along path. Again, that just gives me a plane to work on with this. I'm going to select it to the back face, makes it easier. Create a sketch. And now I can sort of see my overhang accordingly, right? So if I want to make a circle now, you can see that if say I were to do a 2.5 gap, you can see that if I were to extrude this, my overhang would be here, right? So now if I decide, you know what, I want there to not be such a steep overhang, and in my experience I find 70 degrees works fine for supports, for printing without supports I mean. So I'll just draw a line here like so, and maybe I'll just give this a little bit of a construction line just to make sure that it is in fact 70. So I'll again dimension this like so, 70. And so now this angle here is what I can print without having supports. If I wanted to, I can use this as a reference basically and make whatever shapes. So in this case, if I wanted to make a block, like a rectangular cutout, I can. I'm not going to use this, it's just sort of an example to show that how I can use sketches as referencing as well for tools. Delete, takes time, delete. So in this case, I still want a circle, but I don't want it to have an overhang. It's very simple. Instead of having my circle be constrained to this line, what I can do is I can just delete this. I'll create a circle anywhere for now. Again, I'll make this 2.5. And I can position it such that I go here. So I do my circle about here. You can see that if I were to cut it out, the overhang isn't as high. And if I bring it out, you can see that the overhang is even better in this case. So I'll just put a circle here. I'll still want to be in the center. I'll draw a line from the middle point here. I'll make a construction line. Click and drag, and now I can make sure it's aligned in the center always. So I was quite happy with this. I'll just leave it there.
You can also use ellipses, right?
You can if you want, yeah. It's just an example of what you want. So now I'll cut a rail and I'll just cut it out to here. Let's just say. Again, I can always select this face there and I'll say I want it to go back. So I'll just go minus 2.5 just to show that you can still use equations. Enter, and now I have a rail that should be able to print without any supports, right? And so with that, I can always make a complementary face to my lid. So I'll put it here, show my lid. I don't need to show my box. I will bring up my previous sketch here, which is a circle. And now if I select that circle, you can see it's still on the face, that's fine. I will again bring it back up to here. And again, remember I didn't actually go there. So what I can do is instead of doing that, I can always just drag this back out. Go back to my box. Hide my lid. Select that face. Remember to hide, show your lid again. Hide the box because you're going to join. Join. Hit OK. And now you have a slot, a rail essentially that can still, as you can see, be printed in one piece without any supports using 3D printing. Of course, if you want, you can always, again with tolerances, just offset the face. I'll offset this by 0.2, 0.4 maybe. Yeah, 0.4 is fine. If you are worried, maybe you want this to be a bit smoother as well, you can fillet the edges. I mean, these are all the tools you have at your disposal, you see. So let me just give it a 0.4 maybe. It might affect the shape, but we'll see. So this is a good thing. We can always check in Fusion, right? So here, if I go back to my section analysis, you can see I have a guide rail. And in this case, it might fall out because I've given it a bit of a massive tolerance. But when you actually print it, it should still be fine. Again, if this isn't working for you, find the tolerance of your printer, adjust accordingly. But now by doing this, I have a sliding box that is aligned so that it won't fall off, it won't droop down, but can still be 3D printed without using supports. So this is sort of an introduction to design for AM using Fusion. In the example I showed, what I did was I extruded this edge here on the sliding box all the way to the end. But if you think about it, let's just hide the analysis and we hide the lid. You can see that we have our rail here, right? And if we actually want our box to be able to slide out, then we need to, or lid, sorry, we need to not have this extend so far out, right? So in this case, what I can do is just very simply move this back, and let's just say I move it to somewhere here. Okay, and if I check, I can see that this, the distance of this little nub is 2.5 millimeters. I can always change it by going back to my extrude and increasing the amount of the length of my extrude. But now with this smaller little nub, you can see that if I show my box, and let's bring back the section analysis, now I have some space to actually move or slide my box around on. If you can sort of visualize it, it might help. Let's see, if I go to analysis, if I hit M to move my box, you can see that now I will be able to move it. Let's go back to the section analysis, we'll create a new one. You can see how this is still aligned, but there is the space for it to actually move. So I'll just make a quick one. I'm in fact going to save myself the time. I'm just going to create a half box, so like so. Okay, I'll offset this. Let's make it about 3. It's fine. Okay, finish sketch. And so now I'm going to make the wall, which you can see from here. Hit OK. And now there's in the tutorial resources, I've given a PDF linking the design of snap fit joints. You can go and look into it. There's more math inside. But what I find works decently well is I will split this body first. Body split, splitting tools, select the middle, that's fine, doesn't really matter. This isn't perfectly centered, but I'm just demonstrating. So what I want is to create a sketch on the side plane so that I can draw my joint. In this case, I'm just going to draw a line through here, through there, at an angle. Again, the more exact dimensions will be in the document, and like so. Okay, and I'm going to just use this to trim. Draw another line to connect everything together. And now I have my face like so. I can always press here to delete my projection, and you can see I've got my whole face. So with that done, what I'm going to do is I'm going to finish, actually what I'll do while I'm here is just create a little box to cut out from the bottom later. What I'll do is I'll press the extrude, I'll cut out the box first from the bottom side. I'll just make this 6, doesn't really matter. Cut, I'll show my sketch. Now I'll add the snap fit joint to the side, putting it to the edge there. I can give it a little bit of an offset, doesn't matter. I'll hit join, but make sure to hide your bottom box, which is here, join, okay. And then now, if you look at it, you should see that it can snap in, right? As you push it in, depending on the material, how flexible it is, it should be able to snap in. If you're always worried, you know, let's just say this is too far, you can always offset it or change it in the sketch. For me, let's just say I don't need it to be that much. I'll just offset it like that. Hit OK. I'll hide the sketch. And I can think, okay, how would I want this to snap in? Maybe I want it to be a little bit easier, less of a snap. I can always fillet this edge and make this a little bit less, a bit more smoother when I'm slotting it through, right? I don't want to scratch my box or break it. Similarly, I can always make it a little bit easier to remove this by adding a chamfer here on this side. However I want. Again, you know, play around with the design. There's a design manual, look online, see what kinds you have. If you want it to be removable or a lot more, because here you can push it in to release it, but if say some designs have you need a flat surface, you can always use curves instead. I find curves are quite useful. Similar to how we did with the sliding door, that should also hold your joint in place without breaking it if you were to try and pull it apart. So that's it. Again, play around, use the resources that I found on the Google Drive. Alright, thanks, that's all for tutorial. Again, practice, practice, practice. The parametric modeling is going to be something that you have to acquire through experience. Good luck.